In September 2023, a company called Huawei walked into a mobile phone launch and said nothing unusual. No press release about semiconductors, no announcement about chips. They just started selling a phone, the Mate 60 Pro. And for about 2 weeks, nobody paid much attention. Then someone bought one, cracked it open, and found something inside that the United States government had spent billions of dollars trying to prevent from ever existing. A 7-nanometer chip, designed in China, built in China, on a sanctions list that was supposed to make it impossible. The reaction in Washington was not calm. Congressional hearings were called within days. Commerce Department officials were dispatched. Intelligence agencies were asked how this happened. And the honest answer, the one nobody wanted to say out loud, was that China had done something the sanctions were explicitly designed to stop. Quietly, without announcing it, without needing a single piece of American equipment to get there. That is what this video is about, not just one chip, not just one phone. But what that chip reveals about where this race is actually headed and why the lead America assumed it had is looking considerably thinner than it did 5 years ago. If this kind of content is useful to you, a like on this video genuinely helps other people find it. Now let us get into what actually happened. Before we talk about what China built, you need to understand why a chip that is 7 nanometers wide is enough to trigger a geopolitical crisis. A nanometer is 1/billionth of a meter. A strand of human DNA is about 2.5 nanometers wide. The transistors inside a 7-nanometer chip are smaller than most things that exist in nature. And the reason that matters is simple. Smaller transistors mean more of them fit on the same piece of silicon. More transistors mean more processing power. More processing power means better artificial intelligence, better weapons guidance systems, better satellite imaging, better everything that a modern military and economy depend on. The country that leads in chip manufacturing does not just lead in consumer electronics. It leads in the technologies that will define the next 50 years. Autonomous vehicles, hypersonic missiles, large language models, quantum computing. All of it runs on chips. All of it requires the most advanced chips available to reach its full potential. America understood this before almost anyone else. And in 2022, it decided to use that understanding as a weapon. The chip export controls announced in October 2022 were the most aggressive technology restrictions any country had imposed on another since the Cold War. Not just chips. Everything needed to make chips. The machines that etch circuits onto silicon. The software used to design those circuits. The chemicals required to purify silicon wafers. The American-trained engineers who knew how to run the equipment. All of it restricted. All of it cut off from China in one sweeping move. The logic was straightforward. Advanced chips require extreme ultraviolet lithography machines. Only one company on Earth makes them, a SML based in the Netherlands. These machines cost $150 million each, weigh as much as a commercial aircraft, and require years on a waiting list just to receive delivery. Without them, the conventional wisdom said, you cannot manufacture chips below 10 nanometers, not even close. China had been trying to buy these machines for years. The United States pressured the Netherlands to stop selling them. The Netherlands agreed. And with that, Washington believed it had effectively frozen China's semiconductor capability at a level too primitive to threaten American dominance for at least a decade. That assumption lasted about 18 months. The Kirin 9000S chip inside the Mate 60 Pro was manufactured by SMIC, the Semiconductor Manufacturing International Corporation, China's largest chip maker. SMIC was already on the American export control list, already cut off from the most advanced equipment, already supposed to be incapable of producing anything near this level. The chip measures 7 nanometers. It is not the world's most advanced. TSMC in Taiwan and Samsung in South Korea are already producing 3 nanometer chips. Apple's latest processors are considerably more powerful. In raw benchmark terms, the Kirin 9000S is not competing at the absolute frontier, but that is not the point. The point is that it should not exist. Under the sanctions framework, under the equipment restrictions, under the software controls, a Chinese company manufactured a chip that was supposed to be physically impossible for them to make. Without ASML's machines. What SMIC appears to have done is use older generation equipment, machines they already owned, in ways those machines were never designed to operate. A technique called multi-patterning, where you run the chip through the lithography process multiple times with extreme precision, stacking layers in a sequence that produces finer features than any single pass should be capable of achieving. It is slower. It is more expensive. The yields are lower, meaning more chips fail during production. But it works. And critically, it produced a 7-nanometer chip, not in a laboratory, but at scale, in volume, inside a commercially available phone sold to millions of customers. That is a completely different kind of proof than a research prototype. It means the process is repeatable, manufacturable, and economically viable enough to ship to the public. There's another dimension to this that almost never gets discussed in mainstream coverage, and it is arguably the most important one. Taiwan currently manufactures over 90% of the world's most advanced chips. TSMC alone produces chips that no other company on Earth can replicate at volume. That concentration of capability on one island sitting 180 kilometers off the Chinese coast is not a coincidence that geopolitical planners ignore. For years, the implicit assumption in Western strategic thinking was that China's inability to manufacture its own advanced chips created a powerful deterrent. A China that could not build advanced semiconductors domestically was a China that needed Taiwan's output. And a China that needed Taiwan's output had a powerful economic reason to avoid military confrontation. Every percentage point of chip independence China gains quietly erodes that calculation. A China capable of producing its own leading-edge chips is a China that faces a fundamentally different cost-benefit equation when it considers its options across the strait. That is not a prediction. It is a structural shift in the variables. And it is one reason why the semiconductor race is being watched not just by engineers and investors, but by defense ministries on 3 continents. The Mate 60 Pro launch exposed something deeply uncomfortable. Export controls are only as effective as your ability to enforce them, and your ability to anticipate what the other side can improvise. America had assumed China needed ASML's machines to cross the 7-nanometer threshold. China found a different path. America had assumed that cutting off chip design software would paralyze Chinese engineers. Chinese engineers spent years building domestic alternatives. America had assumed that restricting equipment servicing contracts would gradually degrade Chinese facilities. Chinese technicians reverse engineered enough of the maintenance knowledge to keep their production lines operational. None of this happened overnight. It happened across years of patient, deliberate, underpublicized work by thousands of engineers at companies and institutions that most analysts in Washington had never heard of. The deeper problem is structural. Semiconductor manufacturing is one of the most complex industrial processes humanity has ever developed. The supply chain for a single advanced chip touches hundreds of companies across dozens of countries. Controlling all of it permanently is not a policy. It is a negotiation that must be renewed every single day against a counterparty that is actively working to reduce its dependence on every component you control. And here's the part that changes everything. Every year that passes, China builds more domestic capability, more domestic equipment, more domestic software, more domestic engineering talent. The sanctions did not halt that process. They accelerated it by removing every strategic reason China had to rely on foreign suppliers for anything. Here's the honest picture. China is not ahead. Not yet. TSMC, Samsung, and Intel are all producing chips that are more advanced than anything China can currently manufacture at volume. The gap at the frontier is real and it is significant. But the gap is closing faster than most Western analysts predicted, and the trajectory matters more than the current position. 5 years ago, most semiconductor experts placed China's indigenous chip capability at least a decade behind the leading edge. Today, that estimate has been revised to somewhere between 3 and 5 years for high-volume advanced production. Given that the entire framework of Western policy was designed to push that timeline further out, not compress it, that revision is a serious strategic miscalculation to reckon with. The 7-nanometer achievement does not mean China has won this race. It means China proved the wall can be climbed. That proof changes the psychology of every engineer, every investor, and every government official working on this problem inside China. It also changes the calculus for every policymaker in Washington who assumed the current strategy was delivering the results it promised. The wall was supposed to stop China. It did not stop China. It slowed China down, and in doing so, convinced China that building every layer of this technology stack domestically was not a strategic option. It was survival. That shift in mindset, more than any single chip, is what America is genuinely scrambling to respond to. If you found this breakdown useful, hit the like button and subscribe so you never miss what we cover next.